Hello everybody and welcome back to the second part of our binary system tutorial. We will pick up where we left off from the last time. We talked about in the previous tutorial we covered the binary system. We now understand what the binary system is and how to convert from decimal to binary. So these two parts here are covered. These two parts, we are done with these two parts. In this tutorial, we are going to talk about range and fractions. So let's start by talking about range. Just a quick recap on what we covered last time. We understand that in any numerical system, whether it's the decimal system or the binary system, we have what's called places, right? Places. And these places have values, right? And we understand that in the binary system, the value of any place equals b raised to the power n minus 1, where b is the rank of this place. So this third place here would be its value, just a quick recap, would equal 2, which is the base raised to the power 3, because it's on the third position, minus 1, that would be 4, 2 raised to the power of 2. Now, to get into the range point or the range issue, someone would say, okay, how many of these places in the binary system will we have? Well, it could be anything, any system. The system itself determines how many of these places it will have. The critical question is, if we have 3 places, for example, what is the maximum number that this binary system can represent? As opposed, let's say, to 8 places. 1, 2, excuse me. Let's get rid of this. So, if we have 8 places, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. If we have 8 places, what is the maximum number that this 8 bits binary system can represent? Well, as a rule of thumb, if we are talking about unsigned binary notation, which is what we are explaining here, and in bits, unsigned binary system. So in this case, the n here would be 8 because these are 8 places, and in bits unsigned binary system, the word unsigned means representing only positive numbers, no negative numbers. So the an in bits unsigned binary system can represent up to, if we're going to call this range, b raised to the power of n minus 1. So you're kind of like using, to get the range, this old equation, and all you're doing is you're moving this minus 1 to be in front of the b. So as an example, or old example right here, if we have a 3 bits unsigned binary system, it is capable of representing values up to 2 to the power 3 minus 1. That would be 2 to the power 3, that is 8 minus 1 equals 7. Now let's double check that. So if we have a binary system that has only 3 places, the biggest number that it could represent would be 7. How we make sure that this is the case? Very simple. This is 2 and this is 4. The maximum number that we can have is, we have all 1s in these places. So 1 plus 2 plus 4 equals 7, which is the maximum number that a 3 bits binary system can represent. If it's an 8, you hear about 64 bits systems, right? So that would be 2 to the power of 64 minus 1. These are the numbers that these systems can represent. If it's an 8 bits, so the maximum value would be 2 raised to the power of 8 minus 1, and that would be 2 to the power of 8 minus 1 would be 265 minus 1, that would be 255. Okay, so I hope you have a good understanding of range, or the maximum number now. Now that we are done with this, we go to our next topic, which is the fractions. So, you know, in the decimal system, you might have like a decimal point, right? And you have places to the right of the decimal point. The same thing happens in the binary system. So, in the binary system, we have places to the right of this point, and we have places, to the left, and we have places to the right on this point. This point here, in the binary system, we're going to call the radix point, because it's binary system, it's not decimal. And just like these places have values, so these places have values as well. And the value of any place of these places equals, I'm going to call this V, base raised to the power minus n. It is this easy. That means the value of this first place is 2 raised to the power of minus 1. That would be half. The value of this place right here, 2 raised to the power of minus 2. That would be 1/4. Here, 1/8. Why 1/8? Because it is the third place, so its value would equal equal base, which is 2 raised to the power of minus 3. That would be 1/2 raised to the power of minus 3. That would be 1/8. Okay. What does this have to do with fractions? It has everything to do with fractions. You just learned how to convert a binary fraction to a decimal one. How? If you have a number like this, right here, and you want to, this is the radix point, you want to convert it to its decimal equivalent, you just need to add up all the ones. This is half, this is 1/4, this is 1/8. So that means add 1/2 plus 1/8. So this equals 1/2 plus 1/8. And that would be equals to 5/8, because this is 4/8. If you use a calculator, this is going to come up to 625. So this is how you represent 625 in binary. Very quickly, let's verify that. Let's say 5/8, 625. Alrighty. Okay. So the question now becomes, and that would be the final part of our tutorial, how do we do the opposite? How do we convert a decimal fraction to a binary one? Let's go over here. So to do that, we are going to follow a very simple algorithm. And first step, let's say that this number that we are trying to convert is x. We'll see if x is greater than or equal to half. If it's greater than or equal to half, right, we will write 1, okay, and subtract half, subtract half from x. Okay? Otherwise, we write 0. Otherwise, we write, sorry, keeps doing this. We write 0. Don't worry if this is a bit confusing. Once I give you the example, it's going to make a lot of sense. Okay, step number 2, multiply x by 2. So multiply x by 2. Step number 3, check to see if x is greater than 0. Two possibilities. If yes, go to step number 1. Step number 1. No, if x equals 0, then you are done. That's it. And the last step would be the binary representation of this decimal fraction would be all the ones and zeros from the top down. Again, this is going to make sense when I give you the example. Let's do the example right away. So it's just a 4-steps algorithm. If you follow, you should be able to convert any decimal fraction to its binary equivalent. We need to start with 0.375. All right? Okay. So according to the algorithm, if this is x, is this larger than or equal, greater than or equal to half? Nope. So we write 0. Simple as this. Second step, multiply it by 2. That would be 750. Okay, number 3. Is it above, if x now, which is this, above 0? Yes, it is. Repeat number 1. All right? Number 1 says, is it above half now? Yes, it's greater than half. So write 1. So here we write 1. And subtract half from x. Okay? So x now equals 200.25. Correct? Because, you know, keep this in mind. Because 0.75 minus half, that's 0.25. The second part is multiply x now, which is 200, which is 0.25, multiply it by 2. And this is going to make it half, 0.5. And is it above 0? Yes, it is. Go to step 1. Now, if you concentrate, all we're doing is we are just repeating this algorithm, and that's the beauty of it. Step 1, is it above or equal to half? Yes, it is. Write 1 again. And subtract half. Half minus half is 0. It is 0 now. Even if you multiply it by 2, still 0. X is above 0? No. So this is the end. Now this part, the last part, is going to make sense now. The binary representation is all the zeros and ones that you got from the top down. From the top down. So we write the radix point, and we write 0, 1, 1. See? 0, 1, 1 from the top down. If you really want to verify that this is indeed the number that we started with, so let's convert it back to, let's convert this binary back to its decimal equivalent. Here we have half, this is 1/4, and this is 1/8. So add those up, 1/4 plus 1/8, 1/4 plus 1/8. That would be 3/8. Why? Because this is 2/8. So 3/8 is, let's use a simple calculator, 3/8 equals, and it is indeed 0.375, which is what we started with. Thank you so much for watching, guys, and I'll see you in the next tutorial.